we have to graph y equals x squared minus 4x minus 5. This is going to be a parabola, and parabolas, quadratic expressions, they get big very quickly. So actually we're going to use this coordinate system. It's harder to see, but the numbers are between negative 10 and 10. I don't think negative 6 to 6 is going to be sufficient for this. So the first thing we're going to do is, before we even graph anything, we're going to factor this by completing the square. So half of the linear coefficient is negative 2. X minus 2 squared is x squared minus 4x plus 4. So we smuggle in that 4. This is the standard form. This will tell us about the vertex. And then we apply the difference of squares theorem. Now we know that 9 is 3 squared. Feel free to skip the line where you repeat this line, but you write 3 squared for 9. Just as long as you're not going to put 9 here. Then you need that line. Now we clean up x plus 1 times x. Alright. So before we even plotted a single point, let's just do this computation really quickly, because there are 3 lines here that tell us quite a lot of what we want. The problem always insists not only to graph the parabola, but to state the coordinates of certain points. With lines, there is no point more important than the other, but in case of a parabola, if a parabola looks like this, and you're substituting a few points like this, you're not capturing the essential part of the parabola. In case of parabola, it's important to find strategies of what x values to use to compute the y value. And this computation will give you the framework for that. This is the form that it was given. I call it the polynomial form. So in the polynomial form, this is the easiest way to put 0 in there. If you put a 0 into an expression, in this case, if x is 0, this is gone, you just pick up the number part. So if x is 0, then y is negative 5. That's the y-intercept. 0, negative 5 is going to be our y-intercept. When you put in x equals 0 and out comes negative 5, the polynomial form is the one that gives that result to you the easiest way. But it should be the same result no matter where you put it. 0 minus 2 is negative 2. Square it, 4. 4 minus 9 is negative 5. 0 plus 1 is 1. 0 minus 5 is negative 5. Multiply 1 and negative 5, you get the negative 5. So these are equivalent equations. No matter what x you put in either one of them, out comes the same y. But for 0, this one is the most convenient. So that's about the y-intercept. For the x-intercept, it has to be the factored form. So now you don't have a choice. The x-intercepts will be told to you only by the factored form. The zero product rule says that this expression, x squared minus 4x minus 5, can only be 0 when x is negative 1 or x is 5. So the factored form tells us where the x-intercepts are. For me, intercepts are not numbers, but ordered pairs of numbers. So it's negative 1, 0 and 5, 0. Okay, negative 1, 0 is here and 5, 0 is here. And at this point, you should have kind of a hunch that how could these 3 points be on a parabola? So we have 3 out of the 4 points, right? We are asked to give intercepts and vertex. And now the most interesting, the part that's new to us is the vertex. So the vertex is where the lowest y value is achieved. So we have the expression x minus 2 squared minus 9. What is the lowest value of this expression? Okay, the lowest value of a quadratic expression has always to do with the square part being 0. So if this part is 0, then y equals negative 9. And what x would do that? X would have to be, you would be solving this cute little linear equation when x minus 2 equals 0, what is x? So what we have is that if x is plus 2, then the lowest value of the y coordinates is negative 9. So the vertex's 2 coordinates are 2, negative 9. And now we have enough points that it should fit. So we have 2 and negative 9. I'd rather go negative 9 and then. So this is the vertex. And so it looks like it makes sense. All right. So we have the y-intercept 0, minus 5. The x-intercepts minus 1, 0, and 5, 0, and the vertex is 2, negative 9. Now the problem asked for 5 points, including these 4. So where do we get the 5th point? Well, we have all these equations, and we can use any x to put in and find y. Now, I would use x values close to the vertex. The vertex is x coordinate is 2. I would use 1 or 3, but 0 is already taken. So I wouldn't go negative 10, because if you go negative 10, the parabola is way up. So it's, in practical terms, it's useless. You can state it in just writing down the numbers, but it's not going to help with the graph. Let's say this is the standard form, right? This gave you the vertex, the 2 coordinates of the vertex, but it does other things too. So this is completely unnecessary. I just want to show you something. So 2 is where the vertex is, right? When x is 2, then y is negative 9. Let's put in 3 and 1 because I want you to see what happens. If x is 3, then 3 minus 2 is 1, 1 squared is 1, 1 minus 9 is negative 8. So we just found 3, negative 8. Now, what happens if we put 1 into this formula? 1 minus 2 is negative 1. We had 3 minus 2, that was plus 1. 1 minus 2 is negative 1. We square it, plus 1 minus 9 is negative 8. So we get the same value on the left of the vertex as on the right of the vertex. Let's see again. If we go 1 to the left, that's 0, and for 0 we already know that the answer is negative 5. What if we go 1 unit the other way around? 4. Well, 4 minus 2 is 2, and 2 squared is 4, and 4 minus 9 is negative 5. Here we square negative 2. Here we square 2. So there is this outer symmetry, and this symmetry still has to do with the fact that a number and its opposite square to the same thing. So that's going to give a very nice visual symmetry. See, and the center of symmetry is where the vertex. Also, it's kind of good manner to not to stop at the x-axis, but basically go until a picture allows you. Let's see, negative 2. Because we start with negative 2, subtract 2, now it's negative 4, square 16, 16 minus 9 is 7. So when x is negative 2, we're already up at 7. And so if we put negative 3 here, we're going to be off the paper, because negative 3 minus 2 is negative 5, square it, 25, subtract 9 is 16. And this just stops at 10. So before we reach x equals negative 3, this parabola is already off the picture. And then the whole picture is highly symmetrical. So you can predict a point here from negative 1, 2, 3, 4. So 4 to the other direction. There, that's going to be a point 2. And we can use algebra to check it. This would be x equals 6. So if x is 6, then 6 minus 2 is 4. 4 squares to 16, we get the same 7. Highly symmetrical. Thank you for watching.